Chapter 3, we're going to be looking at solving quadratic equations. So a quadratic equation one variable is an equation that can be written in the standard form ax squared plus bx plus c equals 0. A, b, and c are real numbers, and a cannot be 0. A root of an equation is a solution of the equation. They are also called the x-intercepts of the equation. So when we're solving, we're really looking for the x-intercepts. Where does it hit the x-axis? So these first 4 examples, you're just supposed to graph it on Desmos in order to see if you can find the x-intercepts. So go ahead and pause the video, see if you can graph this on Desmos, graph each equation on Desmos, and see if you can identify the x-intercepts. So I'm not asking you to graph it by doing negative b over 2a, just go ahead and do it on Desmos. All right, if you graph this on Desmos, what you would notice is that you would have got negative 3, 0, and 2, 0 as the x-intercepts. So you have 2 x-intercepts. For letter B, you would only get 1 x-intercept, negative 1, 0. You had to set it equal to 0 in order to plug it into Desmos. So if it didn't work, that is why. Now, letter A, you would get 2, 0, and 6, 0 are the x-intercepts. And letter B, you only get 1 x-intercept at 3 halves 0. So let's just kind of review as we can solve by graphing, but sometimes that's not the most efficient. So what we're going to do is we're going to go ahead and try to solve using square roots. When solving quadratic equations using square roots, you can use properties of square roots to write your solutions in different forms. When a radicand in the denominator of a fraction is not a perfect square, you can multiply the fraction by an appropriate form of 1 to eliminate the radical from the denominator. This process is called rationalizing the denominator. So we must rationalize the denominator anytime we see a square root in the denominator, or if we see, like, for example, square root of 25 over 4. We have to simplify it. So let's try these examples. Solve quadratic equations using square roots. So 4x squared minus 31 equals 49. So we notice that this is the form ax squared plus bx plus c. Now when we're solving with square roots, we notice we don't have a b value, the middle term. So we just have the square and we have constants. So let's go ahead and combine our constants together. So 31. So we have 4x squared equals 80. Then to isolate the square, we divide by 4. So our goal is to isolate the squared value. So we have x squared equals 20. Then we square root both sides. Remember, when you square root both sides, that you do get a plus or minus. So x equals plus or minus square root of 20. Then square root of 20, we can simplify that further. Square root of 20 is 4 times 5, or 2 times 2 times 5. So this is 2 times 2 times 5. So the pair comes out, so it's 2 root 5. So x equals plus or minus 2 square root of 5. And then it just depends. Sometimes you have to write it into separate terms. So x equals 2 root 5 and x equals negative 2 root 5. Let's try letter B. So let's subtract 9 from both sides first. So we get 3x squared equals negative 9 divided by 3. And we notice that x squared equals negative 3. If we take the square root, notice that we have a negative inside, and we're not allowed to have a negative inside. So for right now, we're just going to say that there is no real solutions. Okay, because we have a negative inside. So for now, when you see that, just get down to this spot and say no real solutions, and then I will know because you have a negative in the square root. Letter C. We have 2/5 x plus 3 squared equals 5. So the first thing we want to do is we want to isolate this squared value here. And so we need to take care of this fraction. So one way to do it, there's 2 ways you can do this. Number 1, you can multiply by the reciprocal, which is you would multiply by 5 over 2. Or we can clear the fraction first, which is very similar, and you'll see it's the same. You would get the same answer. Let's go ahead and clear the fraction. We multiply by 5 to both sides. So the 5 clears from that side, and so the left side is now 2 times x plus 3 squared equals 5 times 5, which is 25. then we can divide by 2 in order to isolate that squared value. So we have x plus 3 squared over, and then let's leave it as 25 over 2, okay? You want to make sure that you don't distribute the 2/5 inside. You can't, because remember PEMDAS. You're actually supposed to just do the exponent first, and please don't do that, because that's going to make this a lot longer than it needs to be. We're solving by square roots. So isolate the squared value. Now what we do next is what we did before, is we square root both sides. So now we get x plus 3 equals plus or minus, let's split it up, square root of 25 over square root of 2. Then we get x plus 3 equals plus or minus square root of 25. Well, we remember that is 5 times 5, and that's perfect. So that's 5 over square root of 2. Now, if you remember from the homework, the 3.0 homework, we need to rationalize the denominator. In order to get rid of that square root in the denominator, we multiply the top and the bottom, numerator and denominator, by square root of 2, whatever that denominator is. So when we do that, now the top will become 5 times square root of 2, and then think about square root of 2 times 2. That is just a regular 2. And we still have this x plus 3 equals the plus or minus 5 root 2 over 2. Last thing is subtract 3 from both sides. And so now we have x equals negative 3 plus or minus 5 root 2 over 2. Now it's helpful if you insert when you're adding or subtracting the value, insert it in front of the plus or minus, so that way you don't mix it up. I have students that always mix it up, where they put it in the back and then they make that the plus or minus, which changes the problem. So if you insert it here, make a space, insert it in here, you're less apt to make that small mistake. Try these 3 examples down here. It's very similar to the top. All right, if you tried this out, number 1, you would have divided by, subtracted 1, and you would have gotten negative 7 divided by negative 2. So negative over negative is positive, so that's okay. Then you square root, you get square root of 7 over square root of 2. Rationalize the denominator by multiplying it by square root of 2 over square root of 2. And then, so because they're both under the radical, that multiplies together, and they're inside the radical, square root of 14. And then square root of 2 times square root of 2 is just 2. Don't forget the plus or minus. For number 2, so when you do this, you square root 49, there was a plus or minus, and then you add 4 to both sides. So when you have the plus or minus inside, that means you have 2 separate equations. So you have 4 plus 7, and then you have 4 minus 7, and you evaluate that all the way. So 4 plus 7 is 11, 4 minus 7 is negative 3, so p equals 11, and p equals negative 3. For number 3, so I subtracted 14 from both sides, so I want to try to isolate the squared value. Subtract 14. 20 minus 14 is 6. Then I want to clear the fraction, so I multiply 3 to both sides. And then, so now notice that I have 2x squared equals 18, because 6 times 3 is 18. Then to isolate the square value, divide by 2. So now we're left with x squared equals 9. I square root both sides. So x equals plus or minus 3, or x equals 3, and x equals negative 3.